Okay, let's do some examples of graphing systems of linear inequalities. Up first, we have this system where we have two linear inequalities, and we're going to graph them in the plane and show them what values of x and y make both of those inequalities true. So let's go ahead and graph the first one. So this one's in the form that we like, y equals mx plus b, where the coefficient on x is our slope and b is our y-intercept. So I can go ahead and graph, and I say, well, my y-intercept is -3, so that's 1 point on the line. Y is equal to -3 when x is 0. And then the slope of my line is 1/2, which means every single one that changes in x is going to go up 1/2, or I can think of it as rise over run. It's going up 1/2. Okay, and then I decide that my line is either dashed or solid. Remember this. If it is strictly greater than or strictly less than, then it is dashed. If it is greater than or equal to or less than or equal to, it is solid. So this type is going to be dashed, not actually equal to the line. And because the y values are greater than the line, that means it's going to be shaded above. Okay. Now the second linear inequality in the system, I need to put it in the correct form to be able to graph it more easily. So let's go ahead and move the x's to the other side, and I want to solve to get it with y by itself on the left side. So it's going to be first -6y. I'm going to subtract 12x from both sides. So this is greater than or equal to -12x plus 12. And then I'm going to divide through by -6 on both sides. So -6 divided by -6 is +1. And I did divide by a negative, so that should flip this symbol around. Whenever you multiply or divide by a negative, flip the symbol so it's now less than or equal to. And -12 divided by -6 is a +2. And 12 divided by -6 is a -2. Okay, so this is my new equation. It's equivalent to this equation, but it's just in a form that I like, so I can graph it a little bit easier. So the y-intercept is -2, so it's just above this one. And the slope is +2, so it's going up 2 over 1. And is it dashed or solid? It is solid. So it looks something like that. And every time you graph two lines in the plane, as long as they're intersecting, they will split the plane into 4 parts. And if you look at the intersection and go up, down, left, right, those are the 4 parts. So 1, 2, 3, 4. One of those parts should be shaded twice. So example, this will be shaded twice. The ones next to it will be shaded once, and then across will not be shaded at all. So I have to decide now, looking at this line, which side should be shaded. So I say y is less than, so less than, the y value is less than the line would be below, so I expect this to be shaded below that line. Okay, so where they overlap is in this area. This is the area where they should both be true. So let me go ahead and check a solution here. How about this is 1, right? Because I went up 2 over 1. So let's look at this point right here. It is 2 in the x and 0 in the y. So it should make both of those statements true. So let's look at the top one. 0y isn't greater than 1/2 times 2 minus 3. This is equal to 1. 1 minus 3 is -2. And that is correct. 0 is greater than -2. So it checks out. And let's check the other one. 12 times 2 minus 6 times, I'm looking at this equation right here. 0, is it greater than 12? So that's going to be equal to 0. 12 times 2, yeah, it's going to be greater than 12. So those both check out. All right, let's go ahead and look at using the computer. And we're going to do this common counting practice here. It'll be difficult for you to get 3 in a row because there's a lot of things to check on these. So here's the thing. You have to check to make sure the shading's on the right side. You have to check to make sure it's either dashed or solid. Right now I can tell you they both are solid because they are also equal to. So that's good. You have to check the slopes of the line and the y-intercepts. So let's go ahead and, this one's going to be easy, right? I need to put my y-intercept at +1. And there it is. And the slope of my line is -3/5, so it's going down by 3. 1, 2, 3, open by 5. So 5 and down 3. That's okay. So I feel pretty confident about this one. Now let's graph that one, and it's not in the form that we like. So I'm going to write that on my paper, and I encourage you to also write it on your paper when you're doing these, because it's easy to make mistakes. So let's go back over there. So this is my equation, 14x plus 10y is greater than or equal to 50. So I'm going to move my 14x to the other side. So 10y is good. So I'm subtracting 14x plus 50. Now I divide everything by 10. So when I'm dividing by a positive, so I don't flip the sign. So y is greater than or equal to, let's see, I could reduce this fraction 7 over 5, right? -7 over 5x. And this one I can reduce to 5. So my equation is y is greater than or equal to -7/5 x plus 5. So let's put that graph. Alright, so my y-intercept was +5. The slope was -7/5. So I'm going down by 7, so 5 and 2 more. And then I'm going over 5, which would be right there. Alright, so I have another intersection point. Okay, so was it supposed to be shaded above or below? I got that it was y was greater than. I didn't flip the symbol, so it's still greater than. If it was a negative y, I would have to flip the symbol, right? So it's all the y values that are greater than the y, and those would be above. So it looks like I'm shaded on the right side. Okay, so I think I have everything right. You just want to be sure you have everything right, because to get 3 in a row, it's easy to make mistakes. So my slope, I feel pretty confident about this one, -3/5, y-intercept of 1. Yeah, okay, I'm going to go ahead and check. Yeah, I got it right. Okay, that's how you do it.